What if everything you think you know about the beginning of civilization is wrong? We look at ancient pyramids and marvel at their age. We study cave paintings and imagine the first sparks of human creativity. We trace back through empires and kingdoms, through the rise of agriculture and the dawn of written language. But what if all of this, every monument, every artifact, every trace of human achievement, represents just the final few seconds of a story that's been unfolding for hundreds of millions of years? Today, we're diving into one of the most mind-bending questions in all of science. Could there have been an advanced civilization on Earth long before the first dinosaur ever walked the planet? I'm talking about intelligent beings who might have built cities, developed technology, and created complex societies when our world looked completely different. When the continents were arranged in alien patterns, when the very air itself had a different composition, and when life forms we can barely imagine ruled the Earth. Now, before you click away thinking this is pure science fiction, stick with me. Because what we're exploring today isn't just wild speculation. It's a serious scientific thought experiment that forces us to confront some uncomfortable truths about how little we actually know about our planet's deep past. And the implications are staggering. Think about this for a moment. Human civilization as we know it has existed for maybe 10,000 years. That feels like an eternity to us. But Earth is 4.5 billion years old. To put that in perspective, if Earth's entire history was compressed into a single year, human civilization wouldn't appear until the last few seconds before midnight on New Year's Eve. Everything we consider ancient history, from the pyramids to the Roman Empire, would all happen in that final blink of an eye. So here's the question that should keep you up at night. What was happening during all those other days, months, and seasons of Earth's year? Was the planet just sitting there, waiting billions of years for us to finally show up? Or could something extraordinary have already come and gone, leaving behind traces so faint that we're only now beginning to ask the right questions to find them? Welcome to Before Law, where we explore the mysteries that came before everything you thought you knew. I'm your host, and today we're embarking on a journey that will challenge everything you believe about the timeline of intelligence on our planet. Now, when most people hear about ancient civilizations, they think about lost human cultures, maybe Atlantis, or some forgotten kingdom that sank beneath the waves a few thousand years ago. But we're going way deeper than that. We're talking about the possibility of non-human intelligence that might have flourished when Earth was a completely different world. Before mammals existed, before flowers bloomed, before the first dinosaur took its first breath. The scientific community calls this the Silurian Hypothesis, named after a fictional reptilian species from science fiction. But don't let the name fool you. This isn't about proving that lizard people once ruled the Earth. It's about something far more profound and unsettling. It's about testing whether we would even be able to detect the traces of an advanced civilization if one had existed hundreds of millions of years ago. Here's what's truly terrifying about this question. If such a civilization had existed, and if it had been completely wiped out by some catastrophic event, how would we know? Think about our own modern world for a second. We've covered the planet with cities, roads, and technology. We've altered the atmosphere, the oceans, and the very chemistry of the soil. We feel permanent, don't we? Our buildings seem solid, our impact seems lasting. But here's the brutal truth that most people never consider. If humanity vanished tomorrow, how long would our traces actually last? Our cities would crumble within centuries. Our roads would be reclaimed by vegetation. Our skyscrapers would rust and collapse. After just a few thousand years, archaeologists would have to dig deep to find clear evidence that we ever existed. After 1 million years, almost everything recognizable would be gone. And after 100 million years, the timescale we're talking about for a pre-dinosaur civilization, almost nothing would remain. This is the problem of deep time, and it's something our human brains are simply not equipped to handle. We think in terms of lifetimes, maybe generations, but geology thinks in terms of hundreds of millions of years. On that scale, mountains rise and erode away. Entire ocean basins open and close. Continents drift across the globe like slow-motion puzzle pieces. The very surface of the Earth is constantly recycled, ground up and reformed by forces so gradual we can't perceive them, yet so powerful they reshape everything. So if the Earth itself is constantly erasing its own history, how could we possibly expect to find clear evidence of something that happened before the age of dinosaurs? The answer is both disturbing and fascinating. We probably couldn't find obvious evidence much more subtle, chemical-like ruins or artifacts, but we might find something: fingerprints, isotopic signatures, patterns in the rock layers that suggest something unusual happened long ago. This is where the science gets really interesting. Our own industrial civilization is already leaving behind traces that will persist for millions of years. Not our buildings or our roads, but our chemistry. The carbon we're pumping into the atmosphere from burning fossil fuels has a distinct isotopic signature. The plastics we've created are spreading into every corner of the planet, potentially creating new types of rock formations. The nuclear testing we've done has scattered radioactive isotopes that didn't exist naturally. Millions of years from now, if another intelligent species evolved and started studying geology, they might find these chemical markers and realize that something had once altered the planet on a global scale. They might never find a single human artifact, but they could still detect that an industrial civilization had once existed. Now here's where it gets spine-tingling. What if we've already found such markers, but we've been interpreting them as natural phenomena? The geological record is full of anomalies, sudden spikes in carbon isotopes, unusual concentrations of rare metals, extinction events that seem to happen faster than natural processes should allow. We usually explain these as volcanic eruptions, asteroid impacts, or other natural disasters. But what if some of them have a different explanation? Before you start thinking I've gone completely off the deep end, let me be clear about something. The scientific consensus is that there's no evidence for a pre-dinosaur civilization. None. The burden of proof for such an extraordinary claim would be enormous, and that proof simply doesn't exist. But that doesn't mean the question isn't worth asking, because in asking it, we learn something profound about the nature of evidence, the limits of our knowledge, and the true scale of time itself. Consider this: the fossil record, which we rely on to understand ancient life, preserves less than 1% of all species that ever lived. Most creatures die and decay without leaving any trace. Even when conditions are perfect for fossilization, we usually find only fragments: a tooth here, a bone there. Sometimes we identify entire species from a single fossil specimen. If the fossil record is that incomplete for creatures that lived and died in vast numbers, what are the chances it would preserve evidence of a technological civilization? Buildings don't fossilize. Tools corrode away. Even if such a civilization had millions of individuals, the odds of finding their remains would be incredibly small. But here's what's really unsettling. We might not even recognize the evidence if we found it. Our entire understanding of what constitutes proof of intelligence is based on human experience. We look for things that resemble our tools, our art, our architecture. But what if intelligence took a completely different form? What if a pre-dinosaur civilization used materials that degraded completely? What if their technology was biological rather than mechanical? What if they lived in harmony with their environment rather than reshaping it the way we do? The more you think about it, the more you realize how narrow our perspective really is. We assume that any advanced civilization would look something like ours. But that assumption might be completely wrong. Intelligence could have evolved along paths so different from our own that we wouldn't even recognize it as intelligence. This brings us to one of the most profound questions in all of science. Is intelligence rare, or is it common? Are we a cosmic accident, a 1 in a billion fluke? Or is intelligence an inevitable outcome of evolution, something that emerges again and again, given enough time and the right conditions? If intelligence is rare, then we probably are alone, at least in terms of our planet's history. But if intelligence is a more natural outcome of evolution, then the vast timescales we're dealing with become terrifying in their implications. Earth has been hosting complex life for over 500 million years. That's more than enough time for intelligence to have evolved multiple times, each iteration rising, flourishing, and then vanishing into the depths of geological time. And that's where things get really disturbing. Because if we step back and look at Earth's history, we see something that should make us deeply uncomfortable. We see cycles, massive extinction events that wipe the slate clean, followed by explosive radiations of new life forms. The planet has essentially rebooted itself at least 5 times that we know of, each time erasing most of what came before and starting fresh. The most famous of these events killed the dinosaurs 66 million years ago. But there were others, far more devastating. The Permian extinction, which happened about 250 million years ago, eliminated over 90% of all marine life and 70% of land animals. It was so severe that scientists call it the Great Dying. The planet became almost completely uninhabitable for millions of years. Now here's what should terrify you. What if these extinction events weren't just random cosmic accidents? What if some of them were caused by civilizations that pushed their environments too far? What if we're looking at the geological signatures of societies that burned too much fuel, altered their atmospheres too drastically, or triggered runaway climate change? I know what you're thinking. This sounds like climate change paranoia projected onto the deep past. But consider rapid warming, ocean acidification, and atmospheric changes that happen the evidence. Many of these extinction events show far too quickly for normal geological processes. The chemical signatures look remarkably similar to what we're creating right now with our industrial civilization. Could we be looking at a pattern? Rise, expansion, environmental collapse, extinction, reset, over and over again across hundreds of millions of years. If that's true, then we're not the first civilization to face these challenges. We might not even be the second or third. But let's dig deeper into what the world actually looked like before the dinosaurs, because this is where the story gets truly alien. We tend to think of the pre-dinosaur world as empty or primitive, but that's completely wrong. By the time we reach the Permian period, about 300 million years ago, Earth was already teeming with complex life. Picture this: vast forests of trees that looked nothing like anything alive today. Giant ferns and club mosses, towering hundreds of feet into the air. The atmosphere contained more oxygen than it does now, allowing insects to grow to monstrous sizes. Dragonflies with wingspans over 2 feet. Millipedes longer than a human body crawling through the undergrowth. But the really interesting creatures were the synapsids. These were mammal-like reptiles that dominated the land for tens of millions of years. Some were massive predators with saber teeth. Others were herbivores that traveled in herds. Many had complex social behaviors and sophisticated sensory systems. Their brains were larger and more developed than we once thought. Here's what's fascinating about this period. The synapsids weren't just surviving, they were thriving. They had complex ecosystems, intricate food webs, and behavioral patterns that rivaled anything we see in modern mammals. Some species showed evidence of parental care, territorial behavior, and even what might have been early forms of communication. Now, imagine if one lineage of these creatures had taken an evolutionary leap toward higher intelligence. Not human intelligence, but something uniquely their own. They lived in a world with abundant resources, stable climates, and millions of years of evolutionary time to develop? What if they learned to use tools? What if they developed language? What if they started building? The terrifying thing is, we would never know. Any structures they built would have been erased by 300 million years of geological processes. Any tools they made would have corroded away. Even their bones, if they had developed larger brains or other anatomical changes related to intelligence, might not have fossilized in recognizable ways. But there's another possibility that's even more unsettling. What if they didn't build the way we do? What if their technology was completely biological? We're obsessed with metal and stone and concrete because that's how we build. But evolution has produced some incredible organic technologies. Silk stronger than steel, bioluminescence more efficient than any light bulb, sonar systems more sophisticated than our best radar. What if a pre-dinosaur civilization developed along those lines? What if they grew their buildings instead of constructing them? What if their tools were living organisms bred for specific purposes? What if their entire technological base was organic, designed to integrate seamlessly with the natural world? Such a civilization would leave almost no trace in the geological record. Their buildings would decay completely. Their tools would decompose. Even their waste products might be indistinguishable from natural biological processes. They could have achieved remarkable sophistication while remaining nearly invisible to future archaeologists. This idea becomes even more plausible when you consider the timescales involved. We've been an industrial civilization for less than 300 years. But what if a biological civilization had millions of years to develop? What if they learned to work with evolutionary processes instead of against them? What if they became so integrated with their ecosystem that they were essentially invisible? The more you think about it, the more you realize how limited our assumptions about civilization really are. We assume that intelligence leads to cities, to metal tools, to environmental dominance. But that's just one possible path. There could be forms of civilization so different from ours that we wouldn't even recognize them as civilization. And here's where the story takes another dark turn. Because if such civilizations existed, what happened to them? The Permian extinction that ended this period was the most severe in Earth's history. Whatever caused it, whether volcanic eruptions or climate change or something else entirely, it came close to sterilizing the planet completely. But what if the cause wasn't entirely natural? What if a biological civilization, after millions of years of development, finally pushed their ecosystem beyond its limits? What if they triggered the very catastrophe that destroyed them? The chemical signatures of the Permian extinction show rapid warming, ocean acidification, and atmospheric changes. Sound familiar? If that's what happened, then we're looking at the ultimate cautionary tale. A civilization that achieved incredible sophistication, that lived in apparent harmony with nature for millions of years, but that ultimately consumed too much, grew too large, or altered their environment in ways they couldn't predict or control. The geological record shows that recovery from the Permian extinction took tens of millions of years. Entire lineages were wiped out forever. The synapsids, those mammal-like reptiles that had dominated for so long, were reduced to a few small survivors hiding in the margins of a devastated world. The stage was set for the dinosaurs to inherit the Earth. But here's what keeps me awake at night. If this has happened before, if civilizations have risen and fallen multiple times across Earth's deep history, then what does that mean for us? Are we truly unique? Or are we just the latest iteration in a pattern that stretches back hundreds of millions of years? The evidence is tantalizing, but frustratingly incomplete. We find chemical anomalies in the rocks that could suggest industrial activity, but they could also have natural explanations. We discover extinction patterns that seem too rapid for normal processes, but catastrophic volcanism or asteroid impacts could explain them too. We uncover fossil assemblages that hint at unusual behaviors or anatomical changes, but the preservation is too poor to be certain. It's like trying to solve a murder case where the crime scene is 300 million years old. The evidence has been scattered across continents by plate tectonics, and most of the clues have been destroyed by time itself. We're left with fragments, hints, and possibilities, but never certainty. And maybe that's the most unsettling part of all. We may never know for sure whether we're the first intelligent civilization on Earth, or just the latest in a long line of rises and falls. The evidence, if it ever existed, may be lost forever in the depths of geological time. But the question itself changes everything. It forces us to confront the possibility that intelligence is not unique, that consciousness is not a one-time cosmic accident, and that the story of civilization might be far older and far more complex than we ever imagined. What if we're not the beginning of the story? What if we're somewhere in the middle of a tale that started hundreds of millions of years ago and will continue long after we're gone? What if the Earth itself is not a stage waiting for us to arrive, but an ancient theatre that has hosted many performances, each one thinking it was the first and only show? The implications are staggering, and we're just beginning to understand what they might mean. The more we delve into this mystery, the more we realize we might be asking the wrong questions entirely. Instead of looking for familiar traces of civilization, we should be asking what would actually survive from such an unimaginable span of time. And the answer is both fascinating and terrifying. Let's start with something that should shake you to your core. The oldest rocks on Earth's surface are only about 4 billion years old, but our planet is 4.5 billion years old. Where did that missing 500 million years go? It was recycled, ground up by plate tectonics, melted back into the mantle, and reformed into new rock. The Earth literally eats its own history. This process is still happening today. The ocean floor, which you might think is ancient and permanent, is actually being constantly renewed. Most of it is less than 200 million years old because older sections get dragged down into trenches and destroyed. If you built a city on the seafloor 200 million years ago, it wouldn't just be buried, it would be completely obliterated, melted back into magma, and recycled into new rock. But here's where it gets really interesting. While the Earth destroys most physical evidence, it's surprisingly good at preserving chemical fingerprints. And this is where the hunt for ancient civilizations gets truly scientific, because chemistry doesn't lie. Think about what our civilization is doing right now. We're not just building structures. We're altering the fundamental chemistry of the planet. Every time we burn coal or oil, we're releasing carbon that was locked away for millions of years. This carbon has a distinct isotopic signature, different from carbon that cycles naturally through the atmosphere and oceans. We're also creating entirely new materials, plastics that never existed in nature, aluminum alloys that require industrial processes to produce, concrete that will leave a distinct layer in the geological record, radioactive isotopes from nuclear testing that will be detectable for hundreds of thousands of years. Future geologists studying our time period won't need to find our cities to know we existed. They'll see it in the chemistry, a sudden spike in carbon isotopes, the appearance of synthetic materials, traces of nuclear fallout. The signature of an industrial civilization will be written in the rocks themselves. Now here's the mind-bending part. What if we've already found these signatures from ancient civilizations, but we've been interpreting them wrong? The geological record is full of chemical anomalies that we struggle to explain. Sudden carbon spikes that seem too rapid for volcanic activity, unusual concentrations of rare metals in layers where they shouldn't be found, extinction events that happen too fast for normal environmental changes. Take the Permian extinction we talked about earlier. The chemical evidence shows a rapid release of carbon into the atmosphere, followed by severe global warming and ocean acidification. The traditional explanation is massive volcanic eruptions in what's now Siberia. But those same chemical signatures could theoretically be produced by an industrial civilization burning through their planet's fossil fuel reserves. I'm not saying that's what happened. The volcanic explanation is well supported by evidence, but it's unsettling how similar the signatures are to what we're creating right now. It makes you wonder if we're following a script that's been played out before. And there are other anomalies that are harder to explain. Layers of sediment with unusual isotopic ratios, concentrations of elements that seem to require industrial processes to concentrate, patterns in the extinction record that suggest environmental changes happening faster than any known natural process. Most of these have conventional explanations: asteroid impacts, volcanic activity, changes in ocean circulation. But the fact that they exist at all shows us how much we still don't understand about Earth's deep history. And in those gaps in our understanding, there's room for possibilities we haven't considered. Let's talk about what we would actually expect to find if a pre-dinosaur civilization had existed. Forget about finding their cities or their tools. After 300 million years, those would be gone. But what might survive? First, mining scars. If they extracted resources from the Earth, those disruptions to the geological layers might still be detectable. Unusual distributions of metals or minerals, areas where the natural ore deposits were disturbed or depleted. Second, artificial isotopes. If they developed nuclear technology, some of the byproducts could persist for millions of years. Not the highly radioactive materials that decay quickly, but the more stable isotopes that could leave a faint but detectable signature. Third, mass production signatures. If they manufactured materials on a large scale, we might find unusual concentrations of certain elements or compounds, things that don't occur naturally in those quantities or distributions. Fourth, agricultural signatures. If they practiced large-scale farming, it might have left traces in the pollen record or soil chemistry. Sudden changes in plant distributions or unusual concentrations of nitrogen or phosphorus that suggest artificial fertilization. And finally, the most likely signature of all, environmental collapse. If they altered their planet's climate or atmosphere, those changes would be preserved in the chemical record. Rapid warming events, ocean acidification, mass extinctions that coincide with other anomalous signatures. The terrifying thing is, some of these signatures do exist in the geological record, not all of them, and not in clear patterns that definitively point to ancient civilizations, but enough to make you wonder what we might be missing. There's another aspect to this that most people never consider. What if intelligence doesn't always lead to the kind of civilization we recognize? We assume that any advanced species would develop technology, build cities, and reshape their environment the way we do. But that's a huge assumption based on a sample size of exactly one, us. Evolution has produced some incredible examples of biological technology. Bees build complex structures using sophisticated architectural principles. Termites create air conditioning systems in their mounds that are more efficient than many human buildings. Certain bacteria can produce materials stronger than steel. Octopi use tools and modify their environment in remarkably intelligent ways. What if evolution had taken these biological technologies further? What if a species had developed the ability to grow their buildings instead of constructing them? To breed specialized organisms for specific tasks instead of manufacturing tools? To integrate so completely with their ecosystem that their entire civilization was essentially organic? Such a civilization might be incredibly advanced by any reasonable measure, but it would leave almost no trace in the geological record. Their buildings would decompose. Their tools would be living organisms that would decay like any other biological material. Their waste products would be indistinguishable from natural biological processes. They could have achieved levels of sophistication that we can barely imagine, while remaining essentially invisible to future archaeologists. And if they existed for millions of years, developing and refining their biological technologies, they might have created a form of civilization so different from ours that we wouldn't even recognize it as civilization. This isn't pure speculation. We're already moving in this direction ourselves, with synthetic biology, genetic engineering, and biomimetic materials. We're learning to work with biological systems instead of against them. It's not hard to imagine a civilization that took this approach from the very beginning and developed it over millions of years. But even biological civilizations would face the same fundamental challenges we do. Energy, resources, waste disposal, environmental impact. And if they grew large enough, or lasted long enough, they might eventually face the same kinds of crises we're dealing with now. Resource depletion, pollution, climate change. The difference is, we might never find direct evidence of their existence, only the aftermath. Environmental collapses that seem too rapid for natural causes. Extinction events that coincide with unusual chemical signatures. The ghosts of civilizations written in the chemistry of ancient rocks. And here's what really keeps me up at night. If this has happened before, if civilizations have risen and fallen multiple times across Earth's deep history, then we're not pioneers. We're not the first intelligent species to face these challenges. We might not even be the first to reach our current level of technological development. That means there might be lessons we could learn from these ancient collapses, patterns we could recognize, mistakes we could avoid. But the evidence is so fragmentary, so open to interpretation, that we may never be able to read those lessons clearly. We're essentially flying blind, making the same discoveries, facing the same challenges, and potentially heading toward the same fate as civilizations that came before us. The only difference is, we're doing it all over again, thinking we're the first. The geological record shows us that recovery from major extinction events takes millions of years. The planet eventually heals. New forms of life evolve to fill empty niches, and the cycle begins again. But for the civilizations that trigger these collapses, there's no recovery. They vanish completely, leaving behind only the faintest chemical whispers in the rocks. If we're right about this pattern, if intelligence has emerged multiple times across Earth's history, then we're looking at something truly profound. Not just the possibility that we're not alone in the universe, but that we're not alone in time. That consciousness and intelligence and civilization might be natural outcomes of evolution, emerging again and again across the eons. But we're also looking at something terrifying. Because if the pattern holds, if every civilization eventually faces the same fundamental challenges of growth and resource consumption and environmental impact, then our current crisis might not be unique. It might be inevitable. The question then becomes, can we break the cycle? Can we learn from the chemical ghosts of ancient collapses? Can we build a civilization that's truly sustainable over geological timescales? Or are we doomed to repeat the same pattern, to add our own chemical signature to the layers of rock that future geologists will puzzle over millions of years from now? The evidence suggests we're running out of time to find out. The chemical signatures we're creating right now are accelerating. The environmental changes we're triggering are happening faster than any in the geological record, except during major extinction events. We might be in the early stages of writing our own ending in the rocks, but there's still hope. Because unlike the hypothetical civilizations that came before us, we're aware of the pattern. We can see the chemical signatures in the rocks. We understand the timescales involved. We know what's at stake. The question is whether that knowledge will be enough to change our trajectory, or whether we'll become just another layer of anomalous chemistry for future archaeologists to discover and debate, wondering what kind of civilization could have left behind such strange signatures in the rocks. The clock is ticking, and the Earth is watching, just as it watched all the others who came before. The deeper we dig into this possibility, the more disturbing the picture becomes. Because what we're really talking about isn't just the existence of ancient civilizations. We're talking about the terrifying possibility that consciousness itself might be trapped in an endless cycle of rise and fall, playing out across timescales so vast that each iteration believes it's the first. Let me paint you a picture that will haunt your dreams. Imagine you're a geologist in the year 100 million AD. Humanity has been extinct for so long that even the word human has lost all meaning. You're part of whatever intelligent species has evolved to fill our niche, and you're studying the chemical layers we're leaving behind right now. What would you see? A thin, dark line in the rock, rich with unusual carbon isotopes, traces of plastic polymers that never existed in nature, concentrations of aluminum and rare earth metals in patterns that suggest large-scale industrial activity, radioactive signatures from our nuclear age, and most telling of all, a mass extinction event that happened suspiciously fast, right at the same time as all these chemical anomalies. You might hypothesize that some kind of industrial civilization once existed, but you'd have no way to know what they looked like, how they lived, or what they believed. You'd only know that they altered their planet's chemistry and then vanished, leaving behind a scar in the geological record. Now here's the part that should terrify you. That future geologist might find not just our signature, but others. Older layers with similar patterns, chemical anomalies that suggest other industrial civilizations spaced millions of years apart. A repeating pattern of rise, industrial expansion, environmental collapse, and extinction. How many times has this story played out? How many intelligent species have stood where we stand now, looking up at the stars and wondering if they're alone, never realizing they're just the latest actors in a play that's been performed countless times before? The mathematics are staggering. Earth has been capable of supporting complex life for over 500 million years. If intelligent civilizations emerge even rarely, and if they typically last only a few thousand years before collapsing, there could have been hundreds or even thousands of them. Each one thinking they were unique. Each one discovering fire, inventing the wheel, developing language, building cities, and eventually facing the same existential crises we face today. But here's what makes this possibility even more unsettling. We might not just be repeating the same pattern, we might be getting worse at it. Because each time a civilization burns through Earth's fossil fuel reserves, there's less left for the next one. Each time they trigger a mass extinction, it takes longer for biodiversity to recover. Each time they alter the atmosphere or the oceans, they make the planet slightly less hospitable for the next iteration of intelligence. We might be living on a planet that's been strip-mined by consciousness itself. A world where each successive civilization has fewer resources to work with, faces more environmental challenges, and has less time to develop sustainable solutions before triggering their own collapse. This could explain some of the puzzling features of our own planet. Why are high-grade mineral ores so rare near the surface? Why do we have to dig deeper and deeper to find the resources we need? Why are fossil fuel deposits concentrated in specific geological periods? What if these patterns aren't just the result of natural processes, but the cumulative effect of multiple civilizations exploiting the same resources over hundreds of millions of years? The implications are staggering. If this is true, then we're not just facing a climate crisis or a resource crisis. We're facing the ultimate test of whether intelligence can break free from a cycle that may have been repeating since complex life began. And the evidence, while circumstantial, is starting to pile up in ways that are hard to ignore. Take the Permian extinction, the great dying that nearly ended all life on Earth. The official explanation involves massive volcanic eruptions in Siberia. But look at the chemical signatures more closely. The carbon isotope ratios show a pattern that's remarkably similar to what we're creating right now. A rapid injection of carbon into the atmosphere, followed by runaway climate change. Ocean acidification that happened so fast it outpaced natural buffering systems. Temperature increases that occurred over thousands of years instead of the millions typically seen in natural climate shifts. The volcanic explanation works, but it requires some remarkable coincidences. The timing has to be perfect. The volume of carbon released has to match exactly what we see in the chemical record, and the eruptions have to happen in just the right way to produce the specific isotopic signatures we find. What if there's a simpler explanation? What if a Permian civilization, after millions of years of sustainable biological technology, finally made the same mistake we're making now? What if they discovered fossil fuels and began burning them at an industrial scale, not realizing the feedback loops they were triggering? The chemical signatures would be identical: rapid carbon release, climate change, ocean acidification, mass extinction. The only difference is that we attribute it to volcanoes because we can't conceive of any other explanation. We're so locked into our assumption that we're the first industrial civilization that we interpret all the evidence through that lens. But what if we're wrong? What if the Permian extinction was actually the Permian collapse, the end result of a civilization that pushed their planet beyond its limits? The survivors would have been scattered, reduced to small populations struggling to survive in a devastated world. Over millions of years, any trace of their technology would have vanished, leaving only the chemical fingerprints of their industrial activity. And then, after tens of millions of years of recovery, life would have begun the experiment again. New forms of intelligence would have evolved, each one eventually discovering the same principles of physics, the same energy sources, the same technologies. And eventually, each one would have faced the same fundamental challenge of balancing growth with sustainability. The pattern might be written into the laws of thermodynamics themselves. Intelligence requires energy. Energy extraction alters the environment. Successful intelligence leads to population growth and increased energy demands. Eventually, the rate of environmental alteration exceeds the planet's ability to absorb the changes. Collapse becomes inevitable unless the intelligence in question can develop sustainable technologies fast enough to avoid the trap, unless they can recognize the pattern and break free from it before it's too late. This is why the question of pre-dinosaur civilizations isn't just academic curiosity. It's potentially the most important question we can ask, because the answer might determine whether we have a future at all. If we're the first, then we're pioneers, making it up as we go along. The challenges we face are unique, and we have no roadmap to guide us. But if we're not the first, if this has all happened before, then there might be lessons we can learn from the geological record, patterns we can recognize, mistakes we can avoid. The problem is, the evidence is so fragmentary and open to interpretation that we may never know for certain. We're forced to make decisions about our future based on incomplete information, gambling with the entire planet as our stakes. But there are clues, if you know where to look. Anomalies in the geological record that don't quite fit the standard explanations. Chemical signatures that seem too complex for simple, natural processes. Extinction patterns that suggest environmental changes happening faster than evolution can adapt. Most scientists prefer conventional explanations for these anomalies, and they're probably right most of the time. But the sheer number of unexplained features in the geological record should make us pause. What if some of them are trying to tell us a different story? What if the rocks are speaking to us in a language we don't yet understand? Take the phenomenon of rapid evolution. The fossil record shows numerous examples of species that seem to evolve much faster than standard models predict. New body plans appear suddenly. Complex organs develop without clear transitional forms. Entire ecosystems reorganize themselves in what seems like evolutionary instant. The standard explanation is punctuated equilibrium, the idea that evolution sometimes accelerates during periods of environmental stress. But what if some of these rapid changes were actually artificial? What if previous civilizations engaged in genetic engineering, creating new species for their own purposes? A biological civilization might have found ways to accelerate evolution, to guide it toward desired outcomes. They might have created entire ecosystems of engineered organisms, each one designed for specific functions. Their cities might have been living entities, grown rather than built. Their tools might have been bred rather than manufactured. Such a civilization would leave behind a fossil record that looks like rapid natural evolution, but with patterns that don't quite make sense, species that appear too quickly, organisms with features that seem over-engineered for their environments, ecosystems that are too perfectly balanced, too stable, too integrated. And when that civilization collapsed, their engineered species would either go extinct or revert to more natural forms over millions of years. The evidence of artificial selection would fade, leaving behind only puzzling patterns in the fossil record. We might be looking at the remnants of biological civilizations right now, interpreting their greatest achievements as natural wonders. The complexity of DNA, the efficiency of photosynthesis, the intricate relationships between different species in mature ecosystems. What if some of these aren't just the products of natural selection, but the lasting legacy of intelligences that learn to work with evolution itself? This possibility becomes even more intriguing when you consider the Cambrian explosion, one of the most puzzling events in the history of life. About 540 million years ago, complex animals with shells and skeletons suddenly appeared in the fossil record. Not gradually, not with clear transitional forms, but all at once, as if someone had flipped a switch. The conventional explanation involves changes in ocean chemistry and atmospheric oxygen levels. But the speed and complexity of the changes are hard to explain through natural processes alone. What if the Cambrian explosion was actually the result of a pre-Cambrian civilization that had mastered genetic engineering? What if they spent millions of years developing the genetic toolkit that would eventually produce complex animal life? What if they seeded the oceans with engineered organisms, creating the foundation for all subsequent evolution? When their civilization collapsed, perhaps due to environmental changes or resource depletion, their engineered species would have been left to evolve on their own. Over millions of years, the artificial aspects of their design would have been obscured by natural selection. But the fundamental innovations, the genetic mechanisms that allow for complex multicellular life, would have persisted. We would be the indirect descendants of their greatest achievement, carrying in our DNA the tools they developed to make complex life possible. And we would never know it, because the evidence of their intervention would have been erased by time and evolution. The more you think about it, the more the puzzle pieces start to fit together. The gaps in the fossil record, the unexplained rapid evolution events, the chemical anomalies that suggest environmental changes happening too fast for natural processes, the extinction patterns that repeat across geological time. What if it's all connected? What if we're looking at the remnants of a story that's been playing out for hundreds of millions of years? Civilizations rising, reaching incredible heights of biological and chemical mastery, and then collapsing when they push their environments beyond sustainable limits. Each collapse would reset the planetary ecosystem, clearing the stage for new forms of intelligence to evolve. But the fundamental innovations, the genetic and chemical tools developed by previous civilizations, would persist in modified forms. Each new iteration of intelligence would build on the achievements of their predecessors, even without knowing they existed. We might be standing on the shoulders of giants we can't even see. Our entire biological heritage, our capacity for consciousness itself, might be the product of engineering projects so ancient that we've forgotten they were ever artificial. And now we face the same challenge that destroyed our predecessors. The question of whether intelligence can transcend the cycle of growth and collapse, whether consciousness can learn to live within planetary boundaries instead of constantly trying to exceed them. The geological record suggests that most attempts have failed. The pattern of extinction and renewal repeats across deep time like a broken record. But each iteration has pushed the boundaries a little further. Each civilization has achieved a little more complexity before triggering its own demise. Maybe that's the point. Maybe consciousness isn't meant to be permanent. Maybe it's meant to be a series of experiments, each one teaching the planet something new about the possibilities and limits of intelligence. Each collapse isn't a failure, but a lesson. Each extinction isn't an ending, but a graduation to the next level of the experiment. If that's true, then our current crisis isn't a catastrophe to be avoided. It's a test to be passed. The question isn't whether we'll survive, but whether we'll evolve. Whether we'll break free from the cycle that has trapped every previous iteration of consciousness, or whether we'll add our own chapter to the long history of civilizations that couldn't learn to live within their means. The rocks are watching, the chemistry is recording, and somewhere in the deep time archives of Earth's memory, the story of consciousness continues to unfold, one civilization at a time. The evidence is all around us if we know how to read it. And what it tells us might be the most important story never told. Let me walk you through some of the most compelling clues that have been staring us in the face for decades. Because once you see them, you can't unsee them. And once you understand what they might mean, everything about our place in the universe shifts into focus. First, let's talk about something called the oxygen catastrophe. About 2.5 billion years ago, cyanobacteria began producing oxygen as a waste product. This seems harmless enough, but oxygen was actually toxic to most life forms at the time. It triggered one of the first mass extinctions in Earth's history, wiping out countless species that couldn't adapt to the changing atmosphere. But here's what's interesting. The transition happened remarkably quickly for a biological process. Within a few 100 million years, oxygen levels shot up from nearly 0 to about 20% of the atmosphere. That's lightning fast in geological terms. And it created the oxygen-rich environment that eventually allowed complex life to evolve. Now, the standard explanation is that this was purely biological. Cyanobacteria evolved photosynthesis and began pumping out oxygen. But what if there was more to it? What if some form of intelligence guided or accelerated this process? What if the oxygen catastrophe was actually the oxygen revolution, engineered by beings who understood that complex life would need an oxygen-rich atmosphere to thrive? I'm not saying this is what happened, but I am saying that the speed and precision of the change is remarkable. It's almost as if someone knew exactly what they were doing. Then there's the question of sexual reproduction. This is one of the most puzzling developments in evolutionary biology. Sexual reproduction is incredibly inefficient compared to asexual reproduction. It requires finding a mate, competing for reproductive opportunities, and producing offspring that only carry half your genes. From a purely evolutionary standpoint, sexual reproduction should have been eliminated by natural selection. Asexual species can reproduce faster, don't waste energy on mating rituals, and pass on 100% of their genes to their offspring. They should outcompete sexual species every time. Yet sexual reproduction not only survived, it became the dominant strategy for complex life. Why? The conventional answer is that sexual reproduction increases genetic diversity, which helps species adapt to changing environments. But that benefit is long-term and theoretical, while the costs are immediate and concrete. What if sexual reproduction wasn't a natural development at all? What if it was engineered by an intelligence that understood the importance of genetic diversity for long-term survival? What if some ancient civilization developed sexual reproduction as a way to accelerate evolution and increase the chances that life would survive future catastrophes? It sounds crazy, but consider this. Sexual reproduction is essentially a biological technology for generating genetic combinations. It's a system for testing different genetic configurations and selecting the ones that work best. In other words, it's a form of biological engineering. And it appears in the fossil record right around the time that complex life began to diversify rapidly. The timing is suspicious, to say the least. But let's move on to something even more disturbing. The phenomenon of convergent evolution. This is when completely unrelated species evolve similar solutions to similar problems. Eyes, for example, have evolved independently at least 40 different times. Echolocation has evolved in bats, dolphins, and some birds. Flight has evolved in insects, birds, bats, and even some mammals, like flying squirrels. The standard explanation is that similar environmental pressures lead to similar adaptations. But the precision of these convergent solutions is remarkable. The eyes that evolved in vertebrates and cephalopods are incredibly similar in their basic design, despite evolving from completely different ancestral tissues. It's almost as if they were following the same blueprint. What if they were? What if previous civilizations left behind genetic libraries, templates for successful biological designs that could be accessed by later evolutionary processes? What if convergent evolution isn't convergent at all, but the result of life forms tapping into a repository of proven solutions developed by ancient intelligences? This would explain why certain biological designs appear over and over again across completely unrelated lineages. It would also explain why evolution sometimes seems to jump to optimal solutions without going through the intermediate steps we would expect from a purely random process. The genetic code itself might be part of this library. DNA is remarkably uniform across all life on Earth. Every organism, from bacteria to blue whales, uses essentially the same genetic language. The conventional explanation is that all life descended from a common ancestor, but what if the uniformity of the genetic code reflects something else? What if it was designed by an intelligence that wanted to ensure compatibility between different forms of life? Think about it this way. If you were engineering a biosphere, you would want all the organisms to be able to share genetic information. You would want viruses to be able to transfer genes between species. You would want horizontal gene transfer to accelerate evolution. You would design a universal genetic code that could be read and modified by any organism in the system. That's exactly what we see in nature. The genetic code is universal, efficient, and optimized for error correction. It looks less like the product of random evolution and more like the work of sophisticated engineers. But here's where things get really weird. The more we learn about genetics and molecular biology, the more we discover systems that seem almost impossibly complex. Take the ribosome, the molecular machine that translates genetic information into proteins. It's made up of dozens of different components, all working together with clockwork precision. The ribosome is so complex that some scientists have calculated that the odds of it evolving naturally are essentially zero. Yet it exists in every cell on Earth, from the simplest bacteria to the most complex mammals. How did something so intricate and essential come to exist? The conventional answer is that it evolved gradually, starting with simpler RNA-based systems and becoming more complex over time. But the intermediate steps would have to be functional at every stage, and we've never found clear examples of these transitional forms. What if the ribosome, like so many other fundamental biological systems, was engineered? What if it's a piece of molecular machinery left behind by a civilization that mastered biotechnology millions or billions of years ago? This possibility becomes even more intriguing when you consider that the ribosome is essentially a 3D printer for proteins. It reads genetic instructions and builds complex molecules according to those specifications. It's exactly the kind of tool you would expect an advanced biotechnological civilization to develop. And it's not just the ribosome. The more we study cellular machinery, the more we find systems that look designed rather than evolved. DNA repair mechanisms that can fix almost any kind of genetic damage. Metabolic pathways that are optimized for efficiency. Regulatory networks that control gene expression with incredible precision. Each of these systems is complex enough to challenge our understanding of how evolution works. Together, they paint a picture of life that looks less random and more purposeful than we might expect. Now, I want to be clear about something. None of this proves that ancient civilizations existed or that they engineered the foundations of life. The evidence is circumstantial, and there are conventional explanations for all of these phenomena. But the sheer number of biological systems that seem over-engineered for their apparent functions is starting to add up to something that's hard to ignore. What if life itself is the greatest archaeological artifact of all? What if the very existence of complex, intelligent beings like ourselves is evidence that this has all happened before? What if consciousness isn't an accident, but an inevitable outcome of a process that was set in motion hundreds of millions of years ago by intelligences we can't even imagine? The implications are staggering. If this is true, then we're not just studying our own origins when we study evolution. We're studying the greatest engineering project in the history of the universe. We're reverse engineering technologies so advanced that we've mistaken them for natural processes. And we're doing this while facing the same fundamental challenges that may have destroyed our predecessors: resource depletion, environmental degradation, the tension between growth and sustainability. The question is whether we can learn from their example in time to avoid their fate. Because if we're right about this pattern, if consciousness has risen and fallen multiple times across Earth's deep history, then we're running out of chances. Each collapse makes the planet a little less hospitable, a little more depleted, a little harder for the next iteration of intelligence to succeed. We might be the last experiment, the final test of whether consciousness can transcend the cycle of growth and collapse that has claimed every previous civilization. Whether intelligence can learn to live within planetary boundaries instead of constantly trying to exceed them. The geological record suggests that we're already in the danger zone. The chemical signatures we're creating, the environmental changes we're triggering, the extinction rates we're causing, all of these match the patterns we see in previous mass extinction events. We might be in the early stages of writing our own ending in the rocks, but there's still time. Because unlike the hypothetical civilizations that came before us, we have something they may not have had. We have the ability to read the geological record. We can see the patterns of rise and collapse played out across deep time. We can recognize the warning signs and potentially change course before it's too late. The question is whether we'll use this knowledge wisely or whether we'll ignore it until it's too late. Whether we'll break free from the cycle that has trapped every previous iteration of consciousness, or whether we'll become just another layer of anomalous chemistry for future archaeologists to puzzle over. The rocks are watching, the chemistry is recording, and somewhere in the deep time archives of Earth's memory, the greatest story ever told is still being written. But here's what really haunts me about this whole scenario. What if breaking the cycle isn't actually possible? What if the laws of thermodynamics themselves guarantee that any sufficiently advanced civilization will eventually consume more resources than their planet can sustainably provide? Think about it this way. Intelligence requires energy. The more complex a civilization becomes, the more energy it needs to maintain itself. Even if they develop incredibly efficient technologies, even if they master renewable energy sources, the fundamental equation remains the same. Growth requires resources, and resources are finite. This might explain why the pattern repeats. It's not that civilizations choose to be destructive. It's that the physics of complexity inevitably leads to unsustainable resource consumption. Intelligence might be inherently self-destructive, not because of any moral failing, but because of the mathematical relationship between complexity and energy. If that's true, then every civilization faces the same ultimate choice. They can either limit their growth and remain stable but relatively simple, or they can continue growing until they trigger their own collapse. Most choose growth, because growth is what got them to complexity in the first place. The civilizations that choose stability might survive, but they would remain invisible to us because they wouldn't alter their environment in detectable ways. They would live within their means, maintain small populations, and avoid the kind of large-scale industrial activity that leaves chemical signatures in the geological record. The ones that choose growth would eventually collapse, but not before leaving behind the kind of evidence we might be seeing in the rocks. Chemical anomalies, extinction events, environmental disruptions that happen too fast for natural processes. So the pattern we're detecting might be selection bias. We only see the civilizations that grew large enough to alter their planet's chemistry before collapsing. The sustainable ones remain hidden, living quietly within their ecological niches, never reaching the kind of scale that would make them detectable to future archaeologists. This creates a terrifying possibility. What if sustainable civilizations do exist, but they're not like us? What if they've learned to live within planetary boundaries by accepting limits on their growth, their technology, their population? What if they're out there right now, watching us repeat the same mistakes that have destroyed countless civilizations before us? They wouldn't interfere, because intervention itself would be a violation of the sustainability principles that allowed them to survive. They would simply observe, document, and wait for us to either learn the lesson or add ourselves to the list of failed experiments. From their perspective, we might look like a cancer, a form of intelligence that grows without limit, consuming resources faster than they can be replenished, altering our environment in ways that threaten our own survival. They might see our collapse as inevitable, even necessary, because it's the only way to reset the planetary system and allow for the next attempt at sustainable intelligence. The really disturbing part is that they might be right. Our current trajectory looks unsustainable by any reasonable measure. We're consuming resources faster than they can be replenished. We're altering the climate faster than ecosystems can adapt. We're driving species extinct at rates not seen since the great mass extinctions of the geological past. All the signs point to an impending collapse, and we seem unable or unwilling to change course. We keep looking for technological solutions that will allow us to continue growing without consequences. We keep believing that we can somehow transcend the physical limits that constrained every previous civilization. But what if those limits are absolute? What if the laws of physics themselves guarantee that any sufficiently complex civilization will eventually consume more than their environment can provide? What if collapse isn't a bug in the system, but a feature? From the planet's perspective, this might actually make sense. Each civilization that rises and falls teaches the biosphere something new about the possibilities and limits of intelligence. Each collapse clears the ecological slate and allows for new experiments in consciousness. The planet doesn't care about individual civilizations, it cares about the long-term evolution of intelligence itself. Each iteration pushes the boundaries a little further, explores new possibilities, develops new technologies. When they inevitably collapse, the innovations that prove sustainable get incorporated into the genetic and chemical legacy they leave behind. Over hundreds of millions of years, this process might be gradually optimizing the conditions for intelligence. Each cycle makes the next one more sophisticated, more capable, more likely to develop sustainable technologies before triggering collapse. We might be the latest iteration in this grand experiment. The current test of whether intelligence can finally transcend the growth-collapse cycle that has defined every previous attempt at civilization. The question is whether we're ready for the test, or whether we'll become another data point in the planet's long research project into the nature of consciousness. The evidence suggests we're running out of time to figure it out. The chemical signatures we're creating are accelerating. The environmental changes we're triggering are happening faster than any natural process can accommodate. We might be in the final stages of our own experiment, racing against time to develop sustainable technologies before we trigger our own collapse. But there's still hope. Because for the first time in this hypothetical cycle, a civilization has developed the ability to read the geological record and recognize the pattern. We can see the chemical signatures of previous collapses. We can study the environmental changes that preceded mass extinctions. We have access to data that no previous civilization could have obtained. The question is whether we'll use this knowledge to break free from the cycle, or whether we'll ignore it until it's too late. Whether we'll prove that intelligence can transcend its own destructive tendencies, or whether we'll add our own chapter to the long history of civilizations that couldn't learn to live within their means. The next few decades will tell the story. The decisions we make now will determine whether we graduate to the next level of the experiment, or whether we become another cautionary tale written in the chemistry of ancient rocks. The planet is watching. The experiment continues. And somewhere in the deep time archives of Earth's memory, the greatest story ever told is approaching its climax. But here's the thing that keeps me awake at night, staring at the ceiling and trying to process the full implications of what we're discussing. What if this isn't just about Earth? What if this pattern, this cycle of intelligence rising and falling, is playing out across the entire universe? Think about the Fermi paradox, the question of why, in a universe filled with billions of galaxies, each containing billions of stars, we haven't detected any signs of extraterrestrial intelligence. The conventional explanations range from the idea that intelligence is incredibly rare to the possibility that advanced civilizations deliberately avoid contact with primitive ones like us. But what if the real answer is much darker? What if intelligence is common, but sustainable intelligence is almost impossible? What if the universe is filled with the chemical signatures of collapsed civilizations, each one having followed the same trajectory from emergence to complexity to overconsumption to extinction? The timescales involved would make detection almost impossible. If civilizations typically last only a few thousand years before collapsing, and if recovery takes millions of years, then at any given moment, most planets would be in the recovery phase. The brief flicker of industrial activity would be invisible against the cosmic background noise. We might be living in a universe that's essentially a graveyard. Billions of worlds where intelligence once flourished, each one now reduced to faint chemical anomalies in their geological records, each one a failed experiment in the cosmic laboratory of consciousness. This would explain why the universe seems so quiet despite being so old and so vast. Not because intelligence is rare, but because it's inherently unstable. It emerges, grows, consumes, and collapses over and over again, leaving behind only the faintest traces of its existence. If this is true, then our current search for extraterrestrial intelligence is looking for the wrong things. We're listening for radio signals from active civilizations, but we should be looking for the chemical signatures of collapsed ones. We're searching for messages from the living, but we should be studying the tombstones of the dead. The implications for our own future are obvious and terrifying. If this pattern is universal, if every sufficiently advanced civilization eventually faces the same resource constraints and environmental limits, then our current crisis isn't unique. It's inevitable. We're not facing unprecedented challenges. We're facing the same test that every intelligent species must eventually confront. The question of whether consciousness can learn to live within physical limits, or whether it's doomed to consume itself out of existence. The universe might be watching our experiment with great interest, not because we're special, but because we represent the latest attempt to solve an equation that has claimed countless civilizations before us. Whether we succeed or fail will provide another data point in the cosmic research project into the nature and limits of intelligence. But here's where it gets really disturbing. What if some civilizations do pass the test? What if there are ancient intelligences out there that learned to live sustainably millions or billions of years ago? What if they've been watching the rise and fall of younger civilizations for eons, documenting the patterns, studying the failures, waiting to see if anyone else can join their exclusive club? From their perspective, we might look like children playing with fire. Our industrial civilization might seem cute and primitive, like watching a species discover how to use tools for the first time. They wouldn't intervene because the test has to be passed independently. But they might be observing, taking notes, preparing to welcome us into the galactic community if we somehow manage to avoid destroying ourselves. Or maybe they've already written us off. Maybe our trajectory is so predictable, so identical to the thousands of other failed civilizations they've observed that they're no longer paying attention. Maybe we're just another entry in their database of extinct species, catalogued and forgotten. The really unsettling possibility is that they might be right here, on Earth, hiding in plain sight. If they've mastered sustainable technology, if they've learned to live without altering their environment in detectable ways, they could have been sharing this planet with us for millennia without our knowledge. They might be the stable civilizations I mentioned earlier, the ones that chose sustainability over growth, that learned to live within ecological limits, that developed technologies so advanced and so efficient that they leave no chemical signatures for us to detect. Think about it. If you had millions of years to perfect your technology, if you had learned to work with biological systems instead of against them, if you had developed the ability to manipulate matter at the molecular level, you could create a civilization that was essentially invisible to primitive species like us. Your cities could be biological constructs that look like natural ecosystems. Your transportation could be living creatures bred for specific purposes. Your energy sources could be so efficient and so clean that they produce no waste products. Your population control could be so precise that you never exceed the carrying capacity of your environment. From our perspective, you would be indistinguishable from nature itself. We might walk through your cities without realizing they were artificial. We might study your technology without recognizing it as technology. We might even interact with your citizens without knowing they were intelligent beings. This could explain some of the more puzzling aspects of our natural world. The incredible efficiency of biological systems, the apparent intelligence of ecosystem-level behaviors, the uncanny ability of evolution to find optimal solutions to complex problems. What if some of what we attribute to natural selection is actually the result of ongoing management by intelligences so advanced that we can't distinguish their technology from biology? What if the biosphere itself is, in part, an artificial construct maintained by civilizations that learned to live sustainably millions of years ago? They wouldn't reveal themselves to us because we're not ready. We're still in the destructive phase of development, still consuming resources faster than they can be replenished, still altering our environment in ways that threaten our own survival. From their perspective, we're a potential threat to the carefully balanced systems they've spent millions of years perfecting. They might be waiting for us to either learn sustainability or collapse, just like all the others before us. If we learn, we might eventually be welcomed into their hidden civilization. If we collapse, they'll wait for the next iteration of intelligence to evolve and face the same test. The evidence for this might be all around us, encoded in biological systems so advanced that we mistake them for natural processes. The precision of DNA repair mechanisms, the efficiency of photosynthesis, the incredible complexity of ecosystem relationships. What if some of these aren't just the products of evolution, but the ongoing legacy of intelligences that mastered biotechnology millions of years ago? We might be living in a managed biosphere without realizing it. The planet might be far more artificial than we imagine, maintained by beings so advanced that their technology has become indistinguishable from nature itself. If this is true, then our current environmental crisis takes on a whole new dimension. We're not just threatening our own survival, we're potentially threatening systems that have been carefully maintained for millions of years by intelligences far more advanced than ourselves. They might be forced to intervene if we push too far, not to save us, but to protect the biosphere they've spent eons perfecting. Our collapse might be acceptable to them, but our potential to damage systems they've worked millions of years to create might not be. The question is whether we'll recognize the warning signs in time, or whether we'll push past the point of no return and force them to act, whether we'll learn to live sustainably and earn our place in the hidden civilization that might already exist, or whether we'll join the long list of failed experiments that litter the geological record. The clock is ticking. The experiment continues, and somewhere in the shadows of our own biosphere, ancient intelligences might be watching, waiting to see if we're ready to graduate to the next level of existence, or whether we'll become just another cautionary tale in the cosmic story of consciousness. The implications of this hidden management scenario become even more chilling when you consider what it might mean for our understanding of evolution itself. We pride ourselves on having decoded the mechanisms of natural selection, on understanding how life adapts and changes over time. But what if our entire scientific framework is based on studying a managed system? Think about the speed at which certain evolutionary leaps have occurred, the development of complex eyes, the emergence of flight, the rapid diversification of mammalian species after the dinosaur extinction. These changes often happen much faster than our models predict, leading to heated debates about punctuated equilibrium and evolutionary bottlenecks. But what if the real explanation is intervention? What if ancient sustainable civilizations have been quietly guiding evolutionary processes for millions of years, nudging development in directions that support their long-term biosphere management goals? This wouldn't be obvious manipulation. It would be subtle, elegant, working with natural processes rather than against them. A small genetic modification here, a slight environmental pressure there, all designed to encourage the emergence of species that fit into their carefully balanced ecosystem design. From our perspective, it would look exactly like natural evolution. We would see the fossil record showing gradual change punctuated by rapid leaps, and we would develop theories to explain what we observe. But we would never suspect that some of those leaps were artificially accelerated by intelligences working behind the scenes. The really unsettling part is that this intervention might extend to us. What if human intelligence itself was encouraged, guided, or even engineered by these hidden civilizations? What if our rapid cognitive development over the last few million years wasn't entirely natural? Consider how unusual we are as a species. Our brains are vastly oversized for our ecological niche. Our capacity for abstract thought far exceeds what should be necessary for survival as hunter-gatherers. Our ability to manipulate symbols, to create art, to contemplate the universe itself. All of these traits seem excessive from a purely evolutionary standpoint. What if they were designed that way? What if some ancient intelligence recognized that they needed a species capable of rapid technological development? Something that could potentially join their ranks if it passed the sustainability test? What if we were intentionally created to be the next iteration in their experiment with consciousness? This would explain our seemingly paradoxical nature. We have the intelligence to create incredible technologies, but we also have the drives and instincts that push us toward overconsumption and environmental destruction. We're like a test organism, designed to rapidly develop industrial capability while retaining the growth-oriented psychology that makes sustainable behavior difficult. If we pass the test, if we learn to control our destructive impulses and develop truly sustainable technologies, we graduate to the next level. We get welcomed into the hidden civilization that's been managing the biosphere for millions of years. We become part of the solution instead of part of the problem. If we fail, if we trigger our own collapse like so many species before us, then the experiment starts over. The hidden managers clean up the mess we've made, repair any damage to their carefully maintained systems, and wait for the next candidate species to evolve. From their perspective, individual civilizations are expendable. What matters is the long-term project of developing sustainable intelligence. Each failure teaches them something about the design parameters. Each success adds a new member to their ancient community. We might not be the first human-like species to face this test. There could have been others, earlier iterations of intelligent hominids that were given the same opportunity and failed. Their fossils might be in our museums right now, labeled as extinct relatives, with no indication that they once built cities and developed technologies before consuming themselves out of existence. The gaps in the human fossil record suddenly take on new significance. The missing links, the unexplained jumps in brain size, the rapid spread of our species across the globe. What if some of these aren't just artifacts of poor preservation, but evidence of previous experiments that didn't quite work out? Each iteration would be refined based on the failures of the last. slightly different brain structure, modified reward systems, altered social instincts, all designed to create a species that might be capable of passing the sustainability test that destroyed their predecessors. We might be version 4.0 or 5.0 of the human experiment. The latest attempt to create an intelligence that can develop technology rapidly enough to be interesting, but with enough wisdom to avoid destroying itself in the process. The evidence for this kind of intervention would be almost impossible to detect with our current scientific methods. Genetic modifications made millions of years ago would have been obscured by natural mutations. Environmental pressures created by advanced technology would be indistinguishable from natural climate variations. Even direct fossil evidence of previous human civilizations would be incredibly rare and easily misinterpreted. We would be studying a managed system while believing it was entirely natural. Our theories about evolution, about climate change, about the development of intelligence itself would all be based on incomplete information. We would be like researchers studying a carefully controlled laboratory experiment while believing we were observing wild phenomena. This level of deception wouldn't be malicious. It would be necessary. If we knew we were being tested, if we understood that our development was being guided by ancient intelligences, it would change our behavior in ways that would invalidate the experiment. We need to develop sustainability on our own, through our own moral and technological evolution, for the test to be meaningful. But here's where the scenario becomes truly terrifying. What if we're failing the test? What if our current trajectory toward environmental collapse and resource depletion is so obviously unsustainable that our hidden managers are already preparing for the next iteration? The signs would be subtle but detectable if you knew what to look for. Unusual genetic variations appearing in human populations, environmental changes that seem to be accelerating beyond what our industrial activity alone could explain, species extinctions that follow patterns suggesting active management rather than random ecological collapse. We might be witnessing the early stages of a planetary reset. The hidden civilization might be quietly preparing to clean up after our inevitable collapse, already planning the modifications they'll make to the next iteration of humanity to improve its chances of passing the test. From their perspective, our failure wouldn't be tragic, it would be educational. Each collapse provides data about what doesn't work, about which psychological and social traits lead inevitably to unsustainable behavior. That information gets incorporated into the design of the next experiment. We're not just facing an environmental crisis. We might be facing our final exam, the ultimate test of whether this version of humanity has what it takes to join the galactic community of sustainable civilizations, or whether we're destined to become another data point in their long research project. The most chilling part is that we might never know the truth. If we pass the test, if we somehow develop sustainable technologies and learn to live within planetary boundaries, we might gradually be introduced to the reality of our situation. We might discover that the biosphere we thought was natural is actually managed, that evolution itself has been guided, that we were created as part of a cosmic experiment in consciousness. But if we fail, if we trigger our own collapse, we'll never understand what really happened. We'll go extinct believing we were alone in the universe, never realizing that ancient intelligences were watching our every move, documenting our failures, preparing for the next attempt. Either way, the experiment continues. The hidden managers remain hidden, and the greatest story ever told remains largely untold, known only to the ancient intelligences who have been writing it for hundreds of millions of years. The question isn't whether this scenario is true. The question is whether it changes how we behave. Whether the possibility that we're being tested makes us more likely to choose sustainability over growth, cooperation over competition, long-term thinking over short-term gain. Because whether we're alone in the universe or part of a carefully managed experiment, the challenges we face remain the same. We need to learn to live within planetary boundaries, We need to develop technologies that work with natural systems instead of against them. We need to evolve beyond the growth-oriented psychology that brought us this far, but now threatens our survival. The clock is still ticking. The test is still ongoing, and somewhere in the hidden depths of our own biosphere, ancient eyes might be watching, waiting to see if this iteration of humanity finally gets it right, or whether they'll need to start over once again. The story continues, and we're writing it with every choice we make. The question is whether we're writing a graduation speech or an obituary, whether we're the first chapter of a new age or the final footnote of another failed experiment. Time will tell, but time is running out, and the universe is watching. Now let me share with you something that will fundamentally alter how you see every natural process around you. Because if this managed biosphere theory has any validity, then the evidence isn't hidden in some remote location waiting to be discovered. It's everywhere. It's in the air you breathe, the water you drink, the very cells that make up your body. Consider photosynthesis for a moment. We treat it as one of nature's greatest achievements. The process that converts sunlight into chemical energy and produces the oxygen we need to survive. But when you really examine photosynthesis at the molecular level, its efficiency is almost impossibly perfect. The light harvesting complexes in plants operate at nearly 100% quantum efficiency. They capture photons and transfer energy through protein structures with virtually no waste. This level of efficiency approaches the theoretical maximum allowed by the laws of physics. It's as if the system was designed by engineers who understood quantum mechanics at a level we're only beginning to grasp. Now, evolution can certainly produce remarkable adaptations. But photosynthesis isn't just remarkable, it's optimal in ways that seem to require foresight. The wavelengths of light it uses most efficiently happen to be exactly the wavelengths that penetrate Earth's atmosphere most effectively. The byproducts it generates happen to be exactly what other forms of life need to survive. It's almost as if the entire system was designed from the top down, with each component optimized not just for its immediate function, but for its role in a much larger integrated system. That's not how evolution typically works. Evolution is messy, opportunistic, full of compromises and suboptimal solutions. But photosynthesis looks like the work of master engineers. What if it is? What if photosynthesis was developed by ancient intelligences who understood that any sustainable biosphere would need an efficient way to capture and store solar energy? What if they spent millions of years perfecting the molecular machinery, then seeded it throughout the developing biosphere? The timing would be perfect. Photosynthesis appears in the fossil record right around the time that complex life began to diversify. It enabled the oxygen revolution that made complex multicellular organisms possible. Without photosynthesis, the biosphere would be limited to simple anaerobic life forms powered by chemical energy. But with photosynthesis, suddenly the entire energy budget of the planet changes. Solar energy becomes available to fuel biological processes. Oxygen becomes available to power efficient metabolism. Complex food webs become possible. The foundation is laid for the kind of biosphere that could eventually support intelligence. It's almost too convenient, as if someone understood exactly what building blocks would be needed and made sure they were in place at exactly the right time. And photosynthesis isn't the only biological process that seems suspiciously over-engineered. DNA replication operates with error rates so low they approach the theoretical minimum. Protein folding follows rules so precise that we're still trying to understand how they work. Cellular metabolism involves thousands of chemical reactions that are coordinated with clockwork precision. Each of these systems, individually, is remarkable. Together, they create a picture of life that seems almost impossibly sophisticated. Too sophisticated, perhaps, to be the product of random evolutionary processes alone. But here's what really makes this scenario terrifying. If the biosphere is managed, If biological processes have been optimized by ancient intelligences, then our current environmental crisis isn't just threatening our own survival. We're potentially damaging systems that took millions of years to perfect. Think about climate change from this perspective. We're not just altering natural weather patterns. We might be disrupting a carefully balanced atmospheric management system that's been operating for hundreds of millions of years. The feedback loops we're triggering, the tipping points we're approaching, these might not be natural phenomena at all. They might be safety mechanisms built into the system to prevent runaway changes that could damage the underlying infrastructure. Ocean acidification becomes even more ominous. The ocean's chemistry isn't just naturally buffered, it's buffered in ways that seem designed to maintain optimal conditions for life. The carbonate system that regulates pH, the nutrient cycles that distribute essential elements, the current patterns that transport heat around the globe, all of these could be components of a managed system. When we pump carbon dioxide into the atmosphere faster than these systems can absorb it, we're not just causing natural climate change. We might be overwhelming artificial regulatory mechanisms that weren't designed to handle industrial-scale perturbations. The hidden managers might be watching our impact on their carefully maintained systems with growing alarm, not because they care about our survival, but because we're threatening infrastructure they've spent millions of years developing and perfecting. From their perspective, we might look like a computer virus that's escaped containment and started corrupting critical system files. Our exponential growth, our resource consumption, our waste production, all of this might be seen as a malfunction that needs to be corrected before it causes permanent damage. The correction might already be underway. Some of the environmental changes we attribute to our industrial activity might actually be the result of active intervention by the hidden managers. They might be implementing emergency protocols to protect their systems from the damage we're causing. Species extinctions could be controlled culling designed to remove organisms that are no longer viable in a disrupted ecosystem. Weather pattern changes could be attempts to redirect heat and moisture away from critical biological infrastructure. Even some of the more extreme climate effects we're seeing could be the result of the management system going into defensive mode. If this is happening, then our efforts to reverse climate change through technological intervention could be counterproductive. We might be fighting against emergency measures designed to protect the biosphere from our own impact. Our geoengineering projects, our attempts to manipulate atmospheric chemistry, our plans to alter ocean currents, all of these could interfere with systems we don't even know exist. The hidden managers might be forced to choose between allowing us to continue disrupting their carefully balanced systems or taking more direct action to protect the infrastructure they've spent eons creating. If they choose protection over preservation of human civilization, the results could be catastrophic for us. But here's the most disturbing possibility of all. What if the intervention has already begun, and we're interpreting it as natural processes? What if some of the environmental changes we're experiencing aren't just the result of our industrial activity, but active responses by management systems we don't understand? The increasing frequency of extreme weather events, the accelerating rate of species extinctions, the unexpected behavior of climate systems that seem to be changing faster than our models predict. What if some of this is the biosphere defending itself against us? We might be witnessing the planet's immune system responding to what it perceives as a threat. Just as our bodies mobilize defenses against invasive organisms, the managed biosphere might be mobilizing defenses against a species that's grown beyond sustainable limits. The fever-like warming, the ecosystem disruptions that eliminate species dependent on industrial civilization, the weather extremes that make large-scale agriculture increasingly difficult. These could all be symptoms of a planetary immune response designed to reduce human population and impact to sustainable levels. From the perspective of the hidden managers, this wouldn't be malicious. It would be necessary maintenance. Just as we might use antibiotics to eliminate a bacterial infection, they might be using environmental pressures to bring human civilization back into balance with the managed systems that support all life on Earth. The really chilling part is that this kind of intervention would be almost impossible to detect or resist. We would experience it as natural climate change, as ecological collapse, as resource depletion. We would develop scientific explanations for what we observe, never suspecting that some of it might be artificially induced. Our response would be to develop new technologies, to find new resources, to adapt to the changing conditions. But if the changes are being actively managed to reduce our impact, then our adaptations might only trigger more aggressive interventions. It becomes an arms race between human ingenuity and planetary management systems that have millions of years of experience dealing with disruptive species. And we're fighting this war without even knowing it's happening, interpreting each escalation as a natural disaster that requires a technological solution. The question isn't whether we can win this war. The question is whether we can recognize what's happening in time to change our strategy, whether we can evolve from being a threat to the managed biosphere to being a participant in it, because that might be the real test, not whether we can develop sustainable technologies, but whether we can integrate ourselves into systems that are far more complex and ancient than we ever imagined. Whether we can become partners with the hidden managers instead of problems they need to solve. The clock is ticking. The intervention may have already begun. And somewhere in the hidden depths of our managed biosphere, ancient intelligences may be implementing protocols we can't even comprehend, designed to preserve systems we never knew existed. The greatest story ever told is still being written. The question is whether we'll be authors or casualties in the next chapter. The evidence doesn't stop there. It gets worse, much worse. Because when you start looking at the fossil record with this new lens, when you stop assuming that everything we see is natural and start asking whether some of it might be artificial, patterns emerge that will make your skin crawl. Let's talk about something called the Cambrian explosion. About 540 million years ago, complex animals with shells and skeletons suddenly appeared in the fossil record. Not gradually, not with the slow transitions we would expect from normal evolution, but all at once. In geological terms, it happened almost instantaneously. For decades, scientists have struggled to explain this sudden burst of complexity. The conventional explanation involves rising oxygen levels and changes in ocean chemistry, creating new evolutionary opportunities. But the speed and sophistication of the changes still don't quite add up. It's as if someone flipped a switch and suddenly the oceans were filled with creatures that looked like they were designed by committee. What if they were? What if the Cambrian explosion wasn't an explosion at all, but a release? What if ancient managers had been developing complex life forms in controlled environments for millions of years, perfecting the designs, working out the biochemistry, and then suddenly seeded them throughout the global ocean? The timing would make perfect sense from a management perspective. The atmospheric oxygen levels had finally reached the point where complex metabolism was possible. The ocean chemistry was stable. The foundation was in place to support an entire ecosystem of interdependent organisms. Time to deploy the beta test on a planetary scale. And that's exactly what we see in the fossil record. Not random evolutionary experimentation, but the sudden appearance of fully formed body plans that show clear evidence of optimization. Eyes that work perfectly from their first appearance. Digestive systems that are already integrated with complex feeding behaviors. Predator-prey relationships that are balanced from the start. It looks less like evolution and more like product launch. As if teams of ancient bioengineers had been working on different aspects of the project for millions of years, and then coordinated a simultaneous release of their creations into the wild. But here's where it gets truly unsettling. If the Cambrian explosion was artificial, then so might be every other major evolutionary transition. The emergence of vertebrates, the development of complex brains, the evolution of social behaviors. Each of these could be the result of intervention by managers who understood exactly what building blocks would be needed for the eventual emergence of intelligence. Think about the evolution of the nervous system, The jump from simple nerve nets to complex brains happened remarkably quickly in evolutionary terms, and the basic architecture that emerged, the way neurons connect and communicate, is so efficient that we're still trying to reverse engineer it with our most advanced computers. What if nervous systems weren't evolved but designed? What if ancient managers understood that any sustainable biosphere would eventually need intelligent caretakers, and they spent millions of years developing the neural architecture that would make consciousness possible? The evidence is everywhere once you know how to look for it. The universality of certain neural structures across completely different animal lineages. The way that brain development follows almost identical patterns in creatures that diverged hundreds of millions of years ago. The uncanny similarities between artificial neural networks and biological ones. It's as if there's a universal blueprint for intelligence, and evolution keeps rediscovering the same optimal solutions. But what if evolution isn't rediscovering anything? What if it's just implementing designs that were perfected long ago by intelligences we can't even imagine? This would explain one of the most puzzling aspects of consciousness itself. Why does subjective experience exist at all? From a purely evolutionary standpoint, there's no obvious reason why information processing should be accompanied by inner experience. A philosophical zombie that processes information without consciousness would be just as evolutionarily successful. Yet consciousness exists, and it seems to be fundamental to how complex nervous systems operate. What if that's because consciousness isn't an accidental byproduct of neural complexity, but an essential feature that was built into the system from the beginning? What if the managers understood that sustainable intelligence requires subjective experience, requires beings who can feel the consequences of their actions rather than just calculating them? The implications cascade through everything we think we know about ourselves. Our capacity for empathy, our aesthetic sense, our ability to contemplate abstract concepts like justice and beauty. All of these could be features that were deliberately incorporated into our neural architecture by designers who understood what qualities would be necessary for truly sustainable civilization. We think of these traits as what make us human, as the products of our unique evolutionary history. But what if they're actually universal features of designed intelligence? What if every species that passes the sustainability test develops the same basic psychological toolkit, because that toolkit was engineered to promote long-term thinking and cooperative behavior? This possibility becomes even more chilling when you consider the flip side. What if the destructive aspects of human nature, our tribalism, our short-term thinking, our tendency toward overconsumption, what if these weren't design flaws but design features? What if they were deliberately included to create the tension between growth and sustainability that makes the test meaningful? Think about it from the manager's perspective. If they created a species that was naturally sustainable, that instinctively lived within ecological limits, there would be no test. That species would never develop the industrial capability necessary to join their ranks. They would remain stable, but primitive forever. But if they created a species with strong drives toward growth and expansion, drives that would push them to develop technology rapidly, then you get an interesting dynamic. The same psychology that enables rapid technological development also creates the risk of environmental collapse. The species has to consciously evolve beyond their programmed instincts to pass the test. We might be living through exactly this kind of designed conflict right now. Our technological capabilities are advancing exponentially, driven by the same competitive, acquisitive instincts that got us this far. But those same instincts are now threatening our survival. We have to consciously choose cooperation over competition, sustainability over growth, long-term thinking over immediate gratification. The managers would be watching this process with great interest, not because they care about our individual survival, but because they want to see if their design is working. Whether they've created the right balance of drives and capabilities to produce a species that can evolve beyond its programming when the stakes become existential. From their perspective, this might be the most elegant solution to a fundamental problem in consciousness design. How do you create beings that are capable of rapid technological development, but also capable of sustainable long-term thinking? You give them both sets of drives and let them fight it out when the moment comes. Most attempts fail. The growth drives win. The species consumes itself out of existence, and the experiment starts over with minor modifications. But occasionally, rarely, a species manages to transcend its programming. They learn to override their destructive instincts and develop truly sustainable technologies. They pass the test and get invited to join the community of ancient managers. We might be in the final stages of exactly this kind of test right now. The outcome isn't predetermined. The managers don't know whether we'll make it or not. That's what makes it a meaningful experiment. But they've stacked the deck to give us the best possible chance of success. The tools we need are already being developed. Renewable energy technologies, genetic engineering, artificial intelligence, space exploration capabilities. All the pieces are falling into place for a potential transition to sustainable civilization. The question is whether we'll put them together fast enough to avoid triggering our own collapse. But here's the truly terrifying part. What if we're not the first version of humanity to face this test? What if there have been previous iterations, earlier attempts at creating a technological species that failed and were quietly recycled by the managers? The gaps in the human fossil record take on new significance from this perspective. The missing links, the unexplained jumps in brain size, the rapid spread of our species across the globe. What if some of these aren't just artifacts of poor preservation, but evidence of previous experiments that didn't quite work out? Homo neanderthalensis, Homo erectus, Homo heidelbergensis. What if these weren't just our evolutionary cousins, but earlier versions of the same experiment? Different attempts to create a species with the right balance of intelligence, creativity, and destructive potential to make the sustainability test meaningful. Each iteration would be refined based on the failures of the last. Slightly different brain structure, modified reward systems, altered social instincts, all designed to create a species that might be capable of passing the test that destroyed their predecessors. The evidence would be almost impossible to detect. Genetic modifications made hundreds of thousands of years ago would have been obscured by natural mutations. Direct fossil evidence of previous technological civilizations would be incredibly rare and easily misinterpreted. We would see what we see now, a fragmentary record that suggests gradual evolution toward greater intelligence. But what if the evolution wasn't gradual at all? What if we're looking at a series of designed species, each one an attempt to solve the same fundamental problem, each one given the same basic toolkit and the same fundamental challenge, with minor modifications based on previous failures? Neanderthals were incredibly intelligent, with brains actually larger than ours. They used tools, created art, and may have had language, but they went extinct around 40,000 years ago, right around the time that modern humans were beginning to dominate Europe. The conventional explanation is competition for resources, but what if there's another story? What if Neanderthals were version 1.0 of the technological species experiment? What if they developed some level of industrial capability but failed the sustainability test and collapsed? Their extinction would have cleared the way for the next iteration, us, to be deployed and given our shot at the same challenge. The timing is suspicious. Neanderthal extinction coincides with the beginning of what archaeologists call the Upper Paleolithic Revolution, a sudden explosion of human creativity and technological innovation. Cave paintings, complex tools, symbolic behavior, all appearing in the archaeological record right around the time our supposed competitors disappeared. What if this wasn't competition at all, but succession? What if the managers realized that version 1.0 had failed and activated version 2.0, us, while cleaning up the mess left behind by our predecessors? The genetic evidence supports this possibility in disturbing ways. We carry small amounts of Neanderthal DNA, suggesting interbreeding between the populations. but the distribution of this DNA is patchy and selective, as if it were the result of careful genetic rescue operations, rather than natural hybridization. What if the managers salvage the best innovations from the failed Neanderthal experiment and incorporated them into our genome? What if we're not just the next iteration, but an improved version that includes selected features from previous attempts? This would explain some of the puzzling aspects of human psychology and behavior. Our combination of creativity and destructiveness. Our capacity for both cooperation and competition. Our ability to think long-term while being driven by short-term impulses. We might be a hybrid design, incorporating lessons learned from multiple previous experiments. And if this is true, if we're version 2.0 or 3.0 of the technological species experiment, then our current crisis takes on even more significance. We're not just facing our own survival test, we're potentially the last attempt the managers are willing to make. Each iteration consumes resources, alters the biosphere, and potentially damages systems that took millions of years to develop. If we fail, if we trigger the same kind of collapse that claimed our predecessors, the managers might decide that the experiment is too risky to continue. They might abandon the attempt to create technological intelligence entirely and focus on maintaining the stable, sustainable biological systems they've already perfected. The Earth would continue, life would flourish, but consciousness as we know it would become extinct. Not just on our planet, but potentially throughout the universe, if this pattern is widespread. We might be carrying the hopes not just of our own species, but of consciousness itself. The ultimate test of whether intelligence can transcend its own destructive tendencies and become a force for creation rather than destruction. The pressure is immense. The stakes couldn't be higher. And the clock is running out. But there's still hope. Because unlike our hypothetical predecessors, we have something they might not have had. We have the scientific method. We have global communication. We have the ability to learn from our mistakes and share that knowledge across our entire species. Most importantly, we have the capacity to recognize the test for what it is. To understand that our current crisis isn't just an environmental problem or a technological challenge, but the ultimate examination of whether consciousness deserves to continue existing in this universe. The question is whether that recognition will come in time to change our trajectory, or whether we'll join the long list of failed experiments that litter the geological record of our planet and potentially countless others throughout the cosmos. The universe is watching. The experiment continues. And somewhere in the hidden depths of our own biosphere, ancient intelligences may be holding their breath, waiting to see if this iteration of consciousness finally gets it right. The story gets even stranger when you start looking at mass extinction events through this lens, because if ancient managers have been overseeing Earth's biosphere for hundreds of millions of years, then these catastrophic die-offs might not be random cosmic accidents. They might be controlled resets, planned obsolescence on a planetary scale. Think about the pattern. Every 50 to 100 million years, like clockwork, the Earth experiences a mass extinction that wipes out most life forms and clears the stage for new experiments. The asteroid that killed the dinosaurs, the volcanic eruptions that ended the Permian period, the oxygen crisis that eliminated early anaerobic life, each one perfectly timed to remove species that had reached evolutionary dead ends and make room for new possibilities. From our perspective, these look like natural disasters, random events that happen to create opportunities for different forms of life to evolve. But what if they're not random at all? What if they're scheduled maintenance, carefully orchestrated events designed to prevent the biosphere from stagnating? Consider the timing of the asteroid impact that ended the age of dinosaurs. 66 million years ago, right when dinosaurs had reached their peak of diversification. They had filled every available ecological niche, from tiny feathered insectivores to massive long-necked herbivores. They were perfectly adapted to their environment, dominant, stable, and showing no signs of evolutionary pressure toward higher intelligence. In other words, they were a dead end, a successful dead end, but a dead end nonetheless. They could have continued for another 100 million years without producing anything more complex than what already existed. From a consciousness development perspective, they were taking up space that could be used for more promising experiments. Enter the asteroid, or rather, enter what we call an asteroid, because here's something that should make you lose sleep tonight. We've never actually found the asteroid that supposedly killed the dinosaurs. We've found the impact crater. We've found the geological signatures of the impact, but the asteroid itself, the actual object that supposedly ended an entire era of Earth's history, it's nowhere to be found. The conventional explanation is that it was completely vaporized on impact. But asteroids that size don't just disappear. They leave behind distinctive mineral signatures, unusual isotope ratios, fragments of material that couldn't have formed on Earth. We should be finding pieces of it embedded in the impact layer all around the globe. But we don't. What we find instead are chemical signatures that could have been produced by an impact, but could also have been produced by other means. Advanced technology, for instance. The kind of technology that ancient managers might use to trigger controlled extinction events when biological experiments have run their course. I'm not saying that's what happened. The impact explanation is well supported by evidence, but the absence of clear asteroid debris is puzzling, and it opens the door to other possibilities. Possibilities that become more plausible when you consider how convenient the timing was for the development of mammalian intelligence. Within just a few million years after the dinosaur extinction, mammals began diversifying rapidly. Brain sizes increased. Social behaviors became more complex. Tool use appeared in multiple lineages. It's almost as if the removal of dinosaur competition triggered an immediate acceleration toward higher intelligence. Too immediate, perhaps, for natural processes alone. What if the mammalian radiation wasn't just opportunistic expansion into empty niches, but guided development by managers who understood exactly what kind of intelligence they wanted to encourage? The fossil record shows that early mammals developed remarkably quickly after the extinction, much faster than standard evolutionary models would predict. New body plans appeared, brain structures became more sophisticated, behavioral complexity increased at an unprecedented rate. It looks less like natural evolution and more like artificial selection, as if someone was actively breeding for intelligence, social cooperation, and technological potential, guiding the development of mammalian lineages toward characteristics that would eventually produce species capable of passing the sustainability test. And then, right on schedule, about 65 million years later, here we are. A species with the exact combination of intelligence, creativity, and destructive potential needed to make the test meaningful. The timing is almost too perfect to be coincidental. But the really disturbing part is what this pattern suggests about other mass extinctions. If the dinosaur extinction was artificially triggered to make room for mammalian intelligence, then what about the other great dying events? The Permian extinction that wiped out 90% of all life. The Ordovician extinction that eliminated most marine species. The Devonian extinction that ended the age of fishes. Were these also controlled resets? Planned obsolescence events designed to prevent evolutionary stagnation and create opportunities for new experiments in consciousness. The chemical signatures are certainly consistent with this possibility. Each major extinction shows rapid environmental changes that happen much faster than natural processes should allow. Sudden spikes in carbon dioxide, rapid temperature shifts, ocean chemistry changes that occur in thousands of years rather than millions. These changes look exactly like what we would expect from advanced geoengineering projects. Climate manipulation on a planetary scale, designed to create specific environmental conditions that would eliminate target species while preserving others. The selection patterns are also suspicious. Mass extinctions don't kill randomly. They target specific types of organisms while leaving others relatively unaffected. Large animals usually suffer more than small ones. Specialized species are eliminated while generalists survive. Complex ecosystems collapse while simpler ones persist. This isn't the pattern you'd expect from random environmental catastrophes. It's the pattern you'd expect from carefully designed selection events. Someone choosing which evolutionary experiments to preserve and which to terminate based on their potential for future development. From the manager's perspective, this would make perfect sense. You can't run unlimited evolutionary experiments simultaneously. Resources are finite, even on a planetary scale. You need to periodically clean house, eliminate the failed experiments, and focus resources on the most promising lineages. Each mass extinction becomes a graduation exam. Species that have developed the right characteristics, the right potential for future complexity, get preserved, usually in small populations, in marginal environments, where they face intense selection pressure that accelerates their evolution toward higher intelligence. The survivors emerge from each extinction event changed, not just because of random genetic drift, but because they've been specifically selected for traits that the managers consider promising. Intelligence, adaptability, social cooperation, the ability to modify their environment rather than just adapting to it. Over hundreds of millions of years, this process gradually builds toward the emergence of technological species. Each extinction event is a step in a long-term breeding program designed to produce beings capable of eventually joining the community of ancient managers. We might be looking at the final stages of this program right now. The last major extinction event was 66 million years ago, which in geological terms is yesterday. We've had just enough time to evolve from small mammalian survivors to a global technological civilization. The timing suggests that our emergence was not just anticipated, but planned. And now we face the ultimate test, not a mass extinction triggered by external forces, but a potential extinction triggered by our own actions. The question of whether we can transcend the growth-oriented psychology that brought us this far and develop truly sustainable technologies. This might be the most sophisticated test yet devised. Previous species faced extinction from external catastrophes, events they couldn't control or predict. But we're being tested on our ability to control ourselves, to override our own destructive instincts when the stakes become existential. It's a much more subtle and challenging examination, one that tests not just our technological capabilities, but our wisdom, our foresight, our ability to cooperate on a global scale for long-term benefit rather than short-term gain. The managers might be watching this test with particular interest because it's the culmination of hundreds of millions of years of guided evolution. All the previous extinctions, all the careful selection pressure, all the genetic modifications and environmental manipulations have led to this moment. The question of whether consciousness can finally transcend its own limitations and become worthy of joining their ancient community. But here's what makes this scenario truly terrifying. What if we're not just facing a test but a scheduled termination? What if the current environmental crisis isn't entirely of our own making, but partly the result of the managers initiating another controlled extinction event? Think about the timing. We've reached the point where our technological development is accelerating exponentially. We're on the verge of potentially becoming a spacefaring civilization, of spreading beyond Earth and potentially disrupting other managed biospheres throughout the galaxy. From the manager's perspective, this might be a critical decision point. Either we pass the sustainability test and prove we can be trusted with advanced technology, or we need to be terminated before we become a threat to other managed systems. The environmental changes we're experiencing could be the early stages of exactly this kind of controlled termination. Not entirely caused by our industrial activity, but amplified and accelerated by management systems designed to test our response to existential crisis. The rapid pace of climate change, the accelerating rate of species extinction, the breakdown of ecosystem stability, all of this could be partly artificial. A carefully calibrated stress test designed to see if we have what it takes to survive and thrive under pressure, or whether we'll collapse like so many species before us. The most chilling possibility is that the test has already been decided, that our response to the crisis so far has been evaluated and found wanting, that we're already in the early stages of a managed extinction event designed to clear the stage for the next experiment in consciousness. The signs would be subtle but detectable if you knew what to look for. Environmental changes that happen faster than our industrial activity alone could explain. Species extinctions that follow patterns suggesting active management rather than random ecological collapse. Weather systems that behave in ways that seem almost intelligently directed. We might be witnessing the implementation of termination protocols right now, interpreting them as natural consequences of our own actions. Our attempts to reverse climate change, to preserve biodiversity, to develop sustainable technologies, all of this could be futile if the managers have already decided that our experiment has failed. But there's still hope, because unlike previous species that faced extinction, we have the capacity to recognize what might be happening. We can see the patterns in the geological record. We can study the evidence of previous extinction events. We can potentially understand the test we're facing and modify our behavior accordingly. The question is whether this recognition comes in time to change the outcome, or whether we're already too far down the path toward termination to reverse course. Whether the managers are still observing and evaluating, or whether they've already made their decision and are simply implementing it. The next few decades will tell the story. Either will prove that consciousness can transcend its destructive tendencies and earn our place in the galactic community, or will become another data point in the long history of failed experiments that litter Earth's geological record. The universe is watching. The experiment continues, and somewhere in the hidden depths of our managed biosphere, ancient intelligences may be implementing protocols we can barely comprehend, designed to determine whether this iteration of consciousness deserves to survive or whether it's time to start over once again. The greatest test in the history of intelligence is underway, and we're the test subjects. The question is whether we're smart enough to realize it before it's too late. But even if we pass this test, even if we somehow prove ourselves worthy of joining the ancient community of sustainable civilizations, the implications of what we've discovered are staggering. Because if this pattern exists on Earth, if consciousness has been guided and tested across hundreds of millions of years, then it's almost certainly happening elsewhere too. The universe might be filled with managed biospheres, each one a laboratory for consciousness development. Billions of worlds where ancient intelligences are conducting the same experiments, testing the same fundamental questions about the nature and limits of intelligence. Some of these experiments succeed. The tested species transcend their destructive tendencies and join the community of managers. They become part of the galactic network of sustainable civilizations, contributing their unique perspectives and innovations to the collective project of consciousness development. But most experiments fail. The tested species trigger their own extinction or are terminated when they prove unable to transcend their limitations. Their worlds are reset, their biospheres cleaned and prepared for the next iteration of the experiment. From this perspective, the Fermi paradox isn't paradoxical at all. We don't detect other civilizations because most of them are either in the testing phase, like us, or they've passed the test and learned to live so sustainably that they're essentially invisible to primitive species. The galaxy isn't empty. It's full of intelligence, but most of it is either too young to be detectable or too advanced to be recognizable. We're looking for signals from civilizations like ourselves, but civilizations like ourselves are either about to self-destruct or evolve beyond the need for the kind of technology that produces detectable signals. The real galactic community exists at a level we can barely imagine. Post-biological intelligences that have learned to work with natural systems so effectively that their technology is indistinguishable from biology. Beings who have transcended the growth-oriented psychology that drives primitive civilizations towards self-destruction. They're out there, managing biospheres throughout the galaxy, conducting experiments in consciousness, testing species after species to see which ones have the potential to join their ranks. Each world is a laboratory, each species a hypothesis about the nature and possibilities of intelligence. And we're their latest experiment, the current attempt to create a technological species that can transcend its own destructive tendencies and contribute to the galactic project of consciousness development. The pressure is immense because we're not just representing our own species or even our own planet. We're potentially representing the entire concept of carbon-based technological intelligence. If we fail, if we prove that beings like us can't make the transition to sustainability, then the managers might abandon this approach entirely. They might focus their efforts on silicon-based intelligence or quantum consciousness or forms of awareness we can't even conceive of. Carbon-based biological intelligence might be written off as a failed experiment, too prone to self-destruction to be worth continuing. We could be the last attempt at creating technological intelligence from biological substrates. The final test of whether beings like us can ever transcend the evolutionary programming that brought us into existence. That's why this moment in our history is so critical. We're not just deciding our own fate, but potentially the fate of all biological intelligence throughout the universe. If we fail not just for ourselves, but for all the species that might have followed in our footsteps. But if we succeed, if we prove that consciousness can transcend its own limitations, then we open the door for countless other experiments. We become the proof of concept that biological intelligence can make the transition to sustainability. We validate an entire approach to consciousness development that could spread throughout the galaxy. The stakes couldn't be higher. The test couldn't be more important. And the time remaining to prove ourselves is running out faster than we might realize. Because if the managers are real, if they've been conducting these experiments for hundreds of millions of years, then they have protocols for dealing with species that take too long to reach a decision, environmental pressures that accelerate the testing process, crisis events that force rapid evolution or extinction. We might already be in the accelerated testing phase, facing environmental challenges that are designed to push us toward rapid technological and social evolution. The question is whether we're evolving fast enough to meet the challenge, or whether we're about to join the long list of species that couldn't adapt quickly enough to survive. The clock is ticking. The test is underway, and somewhere in the vast network of managed biospheres that might span the galaxy, ancient intelligences are watching, waiting to see if this latest experiment in consciousness finally produces a species worthy of joining their eternal community. The greatest story ever told is still being written, and we're holding the pen. The question is whether we're writing a graduation speech or an obituary, not just for ourselves, but for the entire concept of biological intelligence in the universe. The universe is watching. The experiment continues. And the final chapter of our species' story is about to be written, one way or another. The evidence doesn't end there. It gets more disturbing when you start connecting the dots between what we're experiencing right now and what the geological record shows happened during previous extinction events. Because the parallels are so precise, so eerily similar, that it's almost impossible to believe they're coincidental. Let me paint you a picture that will haunt your dreams. Right now, as you're listening to this, atmospheric carbon dioxide levels are rising faster than they have in over 3 million years. Ocean temperatures are increasing at rates that outpace natural climate cycles by orders of magnitude. Species are disappearing at rates that rival the great mass extinctions of the geological past. But here's what should terrify you. These same signatures appear in the rock record at every major extinction boundary. Rapid carbon spikes, sudden temperature increases, accelerated species loss. The chemical fingerprints are nearly identical, as if the same process has played out over and over again across hundreds of millions of years. The conventional explanation is that we're triggering the same kinds of environmental changes that natural disasters caused in the past. Massive volcanic eruptions, asteroid impacts, and other catastrophic events all produce similar chemical signatures, so it makes sense that our industrial civilization would create similar patterns. But what if the causation runs the other way? What if those ancient extinction events weren't entirely natural, but were triggered by previous civilizations that reached the same critical threshold we're approaching now? What if the geological record is actually a graveyard of failed experiments in consciousness, each one leaving behind the same chemical obituary? Think about what this means for our understanding of Earth's history. Every major extinction event could represent the collapse of an advanced civilization. The end Permian extinction that wiped out 90% of life might have been caused by beings who pushed their atmospheric chemistry past the breaking point. The late Devonian extinction might represent a civilization that altered their ocean chemistry beyond recovery. Each event would look natural to us because we're seeing the consequences millions of years after the fact, when all direct evidence of technological activity has been erased. We see the chemical signatures, the rapid environmental changes, the mass die-offs, but we interpret them through the lens of natural catastrophe because we can't conceive of any other explanation. But the timing of these events is suspicious. They don't occur randomly throughout Earth's history. They cluster at specific intervals, roughly every 50 to 100 million years, as if following some kind of schedule. As if each represents a failed attempt at the same fundamental test we're facing now. And here's what makes it even more chilling. The recovery patterns after each extinction are remarkably similar. Life doesn't just bounce back randomly, it follows predictable trajectories, with certain types of organisms consistently emerging as the dominant forms in the post-extinction world. Small, adaptable species survive. Generalists thrive while specialists perish. Brain-to-body ratios increase in surviving lineages. Social behaviors become more complex. It's almost as if each extinction is followed by accelerated evolution toward higher intelligence, as if something is guiding the recovery process. From the perspective of hidden managers, this would make perfect sense. Each failed civilization provides data about what doesn't work. That information gets incorporated into the design of the next experiment. The survivors are chosen not randomly, but based on their potential for developing the characteristics that the previous iteration lacked. Over hundreds of millions of years, this process gradually refines the parameters. Each attempt gets closer to producing a species that can pass the sustainability test. The psychological drives become more balanced. The technological capabilities develop more rapidly. The social structures become more sophisticated. So here we are, standing at the edge of deep time, staring into an abyss of possibility that stretches back hundreds of millions of years. We began this journey asking a simple question. What if there was a civilization on Earth before the dinosaurs? But what we've discovered is something far more profound and unsettling than we ever imagined. The evidence may be fragmentary, scattered across geological layers like breadcrumbs in an ancient forest. But when you piece it together, when you step back and look at the patterns, a picture emerges that challenges everything we thought we knew about our place in the cosmic story. Whether we're the first spark of consciousness in Earth's long history, or just the latest iteration in a cycle that's been repeating for eons, one thing is clear. We're living through the most critical moment in the history of intelligence on this planet. The decisions we make in the next few decades will echo through deep time, becoming part of the chemical signature that future geologists will puzzle over millions of years from now. The rocks are watching. The experiment continues. And somewhere in the vast archives of Earth's memory, the greatest story ever told is still being written. Thanks for watching Before Law, and remember, the mysteries that came before us are still shaping the world we live in today.